Welcome to this Wood Solutions campus presentation on selling and supplying timber and wood products that are fit for purpose in an application outside, in contact with the ground or with salt water. This table is from an earlier presentation and shows the importance of key performance requirements for these applications. They include the most aggressive environments for timber decay and attack by insects or other wood-eating organisms, as well as exposure to wind, sun, rain and sources of abrasion. Timber and wood products used in these applications have to be durable enough to resist these hazards for the required service life. Hazard class 4, 5 and 6 applications include posts, piles, house dumps and utility and agricultural poles on land, and piles, jetty and aquaculture posts in a marine environment. They also include retaining walls and similar landscaping structures. The products used can include timber rounds or sawn timber from high durable species, or materials successfully treated to H4, 5 or H6 treatment levels. These treatment levels align to conditions in each hazard class. To recap on the hazard classes, hazard class H4 is outside in-ground contact. The timber is exposed to moisture in the air and the ground and subject to severe wetting and leaching. The biological hazards are severe decay, borers and termites. Only durable timber or material treated to H4 or above is suitable for use in these applications. Hazard class H5 is timber in critical structural applications that are in contact with the ground. The timber is exposed to moisture and fungi from the air and saturated ground and is subject to extreme wetting and leaching. The biological hazards are very severe decay, borers and termites. Only durable timber or material treated to H5 or above is suitable for use in these applications. Hazard class H6 is in marine waters north and south. The service conditions are that the timber is subject to prolonged immersion in seawater. The biological hazards are marine wood borers and decay. The tidal zone is the most critical location in these hazard class, and there are higher levels of hazard in northern waters than in southern waters. Only highly durable timber or material treated to H6 is suitable for use in these applications. Having determined that the timber is being used in an external application with an aggressive environment, some key performance requirements are clear, while others have to be confirmed through further questions. The performance requirements that are obvious include that the material has to be suitable for H4, H5 or H6 hazard conditions. This means that it has to be a species with high natural durability or be treated to be highly durable. Also, the fixings have to be durable in the expected service environment. Selecting these requires care, as the material in the fixings, usually metals, can react with chemicals in the local environment or within the timber itself and fail quickly. The actual conditions and level of exposure in a H4, H5 and H6 area can vary a lot. Material in a H4 hazard class may be in relatively benign ground conditions, while H6 material can be in a tidal zone and subject to aggressive marine organisms. These levels of exposure need to be confirmed. The follow-up questions to ask include: what is the material's likely exposure in the application? This is particularly important if it is a structural application. Next, has the client picked a species and treatment level? If they have, is the natural durability or the level of preservative treatment of the selected timber adequate for the task? If there is doubt about the material performance, is there an option to alter the selection? Lastly, do special visual performance or coating considerations apply? In a practical sense, issues like material appearance and coatings are less critical than the product's durability. However, both durability and visual performance may be critical to the client. Design for durability is an area of specialist design practice. It is particularly critical for successful specification of material for use in H4, H5 and H6 hazard class applications. Wood Solutions design guides and other courses on the Wood Solution campus provide additional support information on this. All that is possible in this course is to highlight several known problem areas that affect product performance when used in these applications. The first problem area is inadequate product durability. The natural durability of boards or elements may be inadequate, and the material may break down or decay in an unacceptably short time. Material in the ground is especially prone to decay and insect attack in the zone 300 to 400 millimeters above and below the ground line. Inadequate treatment of the product is a related problem. This has two parts. First, the material may not be treated to the correct protection level for the hazard. For example, if the application is a H4 application, in-ground contact, but the treatment is to H3, the material will degrade and prove not to be fit for purpose. The treatment level is inadequate for the application. Next, the material may not have retained the treatment to the required levels. The treatment level may be to a H4 level, but the preservative is not retained in the wood adequately. Generally, the sapwood of softwoods and hardwoods will be treated satisfactorily. However, the hardwood of softwood is difficult to treat, and the required levels of preservation may not be retained. While the hardwood of hardwoods can resist treatment, and the preservative may only enter the envelope of the wood. If the treated sapwood layer is broken, decay and insect can then attack the inadequately protected hardwood. Again, the material will degrade and prove not to be fit for purpose.
But it wasn't enough, so they come up with these treated pine sleepers. Now, I've queried it all along. They're predominantly hardwood because they're coming from the centre of the tree, inactive cells, so they don't absorb, they can't accept the treatment. What happens if the builder breaks the envelope? Okay, he should seal the ends. What happens if it cracks open due to sun? Yeah. Then the moisture gets into the untreatable hardwood. Rots out in no time fast. Pine is durability class 4, not meant to last out in the open.
The last common issue is poor fixing selection. Timber used in contact with the ground, in marine environments or exposed above ground will only last as long as the fixings and metal components used to join them together remain serviceable. This painted steel plate is rusting and will obviously shorten the structure's effective service life. In cases such as this, hot-dipped galvanized steel fittings and fixings may be suitable. However, if the application is in a marine environment or an industrial area, higher durability fixings may be required. In summary, applications outside in contact with the ground or with salt water are in hazard class areas 4, 5 and 6. These applications are the most aggressive environments for timber decay or attack by insects or wood-eating organisms, in addition to exposure to sun, wind and rain. To select a suitable product, questions about the application that should be asked include: what is the material's likely exposure in the application? Has a species and treatment level been selected, and is it likely to be suitable? And do special visual performance or coating considerations apply? Each response will influence the selection of a fit-for-purpose product.